Welcome to Crisis and Perception, where we examine the systems shaping our world, one book at a time. Today, we're tackling something massive. And I don't just mean the page count of the book we're covering, though it is definitely a heavyweight.
It is, yeah.
I mean massive in how it fundamentally changes the way you look at literally everything.
We are diving deep into The System's View of Life by Fritjof, Capra, and Pier, Luigi.
It's a really significant text. I think it's fair to say this isn't just another science book. It's more like a map for a different way of understanding reality itself.
A new map, I like that.
Yeah, it really represents a fundamental shift in the scientific conception of life.
Exactly. And to set the stage for that, we have to talk about the hook of this entire channel, which is the crisis of perception itself. Because when you look around at the headlines today, I mean, it doesn't matter what it is.
Right.
Energy shortages, environmental collapse, climate change, economic inequality, food security. It feels like everything is breaking at once. It can feel overwhelming, for sure, like a cascade of separate, terrifying failures.
But the core premise from this book's introduction is that they aren't actually separate problems. We just treat them that way. You know, we have an energy department for energy, an EPA for the environment, a treasury for the economy.
We put them in silos.
You put them in silos. But Capra and Luisi argue that these are all systemic problems. They're all interconnected and interdependent.
Right. And that is precisely where we usually fail. We try to solve them in isolation.
So that leads to the central question for this deep dive.
Yeah.
Why? Why do these modern crises persist? Why, with all our technology and our supercomputers and our supposed intelligence, do we just seem to be running in circles?
It feels like that sometimes, doesn't it?
It's the old definition of insanity, right? Doing the same thing over and over and expecting a different result.
Precisely. And the answer this book proposes is that we are trying to interpret a living, interconnected world through a completely outdated map.
The wrong map.
The wrong map. We're using what they call a mechanistic or a reductionist model. We're trying to navigate this complex, living web of a world with a map that depicts the world as a machine.
So, to put it simply, we're trying to fix a garden as if it were a clock.
That's a perfect way to put it. And the consequences, the relevance of this is just, it's everywhere.
You see it in ecological collapse. You see it in our health systems that are incredible at fixing a broken bone, but
yeah,
pretty terrible at handling chronic disease.
absolutely. Or you look at financial markets that seem completely detached from the actual physical resources of the planet.
Right?
These are all symptoms of what the book calls fragmented thinking.
They are. And I just want to clarify our mission for this deep dive before we go any further.
Good idea.
This is about paradigms. We are not here to advocate for a specific political party or a specific policy. We're doing a structural analysis of how we see the world. Using the system's view of life as our lens, we're trying to look at the map itself.
Not just the places on the map.
Exactly. So with that, let's get into the minds behind this new map. We've got two authors here, and they are absolute heavy hitters. First up, there's Fritjof Capra.
Capra is, well, he's a physicist and a systems theorist. A lot of people might know him from his much earlier work, like the Tao of Physics.
Right, back in the 70s.
Yeah, where he started connecting modern physics with Eastern mysticism decades ago. But for the last 30-plus years, he's been a key figure at the Center for Eco-Literacy. He spent his career examining the philosophical implications of science.
Asking the big question.
The biggest. Essentially asking, what does our best science actually tell us about who we are and what this world is?
And his co-author is Pier Luigi.
Right. And Luisi is crucial because he brings this very grounded, very real biological and chemical perspective. He's a professor of biochemistry.
So he's in the lab.
He's in the lab. His expertise is specifically in the origin of life and self-organization in complex systems. So you have a physicist who deals with the fundamental laws of the universe.
And a chemist who deals with the messy, tangible reality of biological matter coming together.
Which is rare enough as it is.
It is. Usually those departments are on opposite sides of the campus and they barely talk to each other.
It's very rare. And that collaboration is the whole point, because this book represents what they call a grand synthesis.
A synthesis of what?
Of everything. It's integrating biology, cognition, social science, and ecology into a single coherent framework. It's a genuine attempt to unify the sciences under one systemic understanding of life.
Okay, so to really understand why we need this unification, this new map, we have to understand what we're moving away from. We keep using this word mechanistic, or the machine metaphor. Where did that even come from?
That's the right question. To get it, we have to go back, way back to the scientific revolution.
The 16th, 17th century.
Exactly. This is where the world as a machine metaphor was really born. And it starts, arguably, with Galileo.
Galileo,
Yeah.
the father of modern
A
science.
telescope guy, right? In many ways, yes. But Galileo did something very specific that shaped literally everything that came after him. He said that to effectively study nature, scientists should restrict themselves only to properties that could be measured.
So shapes, numbers, movement.
Quantifiable properties. He called them primary qualities. So if you can put a number on it, it's real science. If you can't, it's just opinion.
Wow.
But there was a flip side to that. He said that all the other properties, the subjective qualities like color, taste, smell, sound, beauty, were merely mental projections.
They weren't real.
Not in a scientific sense. He called them secondary qualities, and they were basically excluded from the domain of science.
That is a huge split.
Yeah.
You're basically saying that the very things that make life feel like life, the smell of a rose, the taste of food, the beauty of a sunset, those don't count as hard reality.
And that obsession with quantification has dominated science ever since. We still have this bias that if we can't measure it, it probably doesn't exist.
It's just noise.
It's just noise. But then you have René Descartes, who took it a giant step further.
Right.
Descartes created the fundamental division of reality into two completely separate realms, mind and matter.
The famous Cartesian split. I think, therefore I am.
That's the one. For Descartes, the material universe was literally a machine, a giant clockwork mechanism. And this part is crucial. He included living organisms in that description.
So an animal is just a machine.
To Descartes, an animal was just a complicated automaton, no feelings, no soul, just gears and levers.
That seems wild to us now. But I guess at the time it was revolutionary because it allowed people to study the body without getting into trouble over the soul.
It did. It absolutely allowed for the progress of physiology and medicine. It was
Yeah.
a useful simplification for a time, but it cemented this idea that to understand something, you have to break it down into its smallest parts.
And then Newton comes along and puts the math to it.
And puts the math to it. Isaac Newton gives us the world machine, a perfect clockwork governed by exact mathematical laws. The idea was that if you could just know the position and momentum of all the parts, you could predict the future of the entire universe.
This is the reductionist dogma. The belief that a complex system is nothing more than the sum of its parts. If you want to understand a frog, you dissect the frog.
If you want to understand a society, you look at the individual. And that brings us, finally, to the core thesis of the system's view of life.
Which is?
That the world as machine metaphor is structurally, fundamentally flawed when you apply it to life. It works great for clocks, it works great for building bridges, but life, mind, society, and ecosystems are not machines.
There's something else.
They're dynamic, interconnected systems. And when you apply mechanistic thinking to living systems, you don't just get the wrong answer, you inevitably produce systemic failure.
Okay, let's unpack that. We've set the stage. We're stuck in this machine metaphor. Now we need to really dig into what the system's view actually is. The book breaks this down into some core insights. The first one is a shift from seeing the parts to seeing the whole.
This is the absolute foundation. In the dominant mechanistic paradigm, we believe the whole is simply the sum of its parts. But in systems thinking, we realize that living systems have what are called emergent properties.
Emergent properties. Okay, that sounds like jargon. Can we ground that a bit?
Let's do it. Think about a simple living cell. Or even better, the book uses this incredible visual. It's figure 7.1 in the text. It shows the metabolic network of a simple bacterium.
And what does that look like?
It looks like an impossibly complex maze, a city map at rush hour, a dense web of thousands of chemical reactions, all happening simultaneously. Now, if you pull out any single molecule from that web, a sugar, an enzyme, a piece of RNA, is that molecule alive?
No, of course not. It's just a chemical.
Exactly. No single part is alive. Life is the pattern of the network. Life is an emergent property of the relationships between the parts. If you chop the cell up into its components, the life just vanishes. You cannot understand a cell or a brain or a society just by analyzing its isolated components.
So life is a property of the whole, not the parts. It's the dance, not the dancers.
That's a beautiful way to put it. It really is the dance. And this leads directly to the second major insight, which is a really cool concept called autopoiesis.
Autopoiesis, okay, that is a mouthful. It was coined by two Chilean scientists Humberto Maturana and Francisco Varela, right?
Yes, two absolute giants in this field. Their work is pivotal to this whole framework, and the word itself literally means self-making.
Self-making.
And this is the book's defining characteristic of a living system. A living system is a network of processes that makes itself from within.
Okay, let's contrast this with a machine. Because you could say a car factory makes cars, but the factory isn't making itself.
Exactly. And a robot is built from the outside. Its parts are distinct. If a part wears out, an external agent, a person, has to come and replace it. But a living cell, it is continually, ceaselessly replacing its own parts using materials and energy from the outside.
So it's constantly rebuilding itself.
Constantly. It maintains its structure, its pattern, even though the physical material inside it is constantly flowing through it.
It's like a whirlpool in a river. The water that makes up the whirlpool is always changing. It's never the same water for more than a second. But the shape, the pattern of the whirlpool remains.
That is a perfect analogy. The book describes it as being operationally closed, but thermodynamically open.
What does that mean?
It's operationally closed in the sense that its organization, its rules, come from within. It manages itself. But it's thermodynamically open in that it has to be open to a flow of energy and matter from the environment to survive. It has to eat.
And the implication here for things like management or government is huge, isn't it? It's about control.
It's all about control. You can drive a car, you can program a computer, you can control a machine, but you can't control a living system in the same way.
No, you really can't.
You can fix a machine, but living systems can only be disturbed or influenced. The book makes this great point. If you kick a stone, you can use Newton's laws to calculate exactly where it will land.
Right, predictable.
But if you kick a dog,
The result is completely unpredictable. The dog might run, it might yelp, it might bite you.
because the dog's response is determined by its own internal structure, it has its own rules, it decides how to react. This is why mechanistic command and control management styles so often fail. They treat people who are autopoietic, living systems like stones, not dogs.
I see that. Okay, this connects directly to the third insight, which is this shift from thinking in straight lines, linearity, to thinking in loops and webs, or nonlinearity.
Yes, the dominant paradigm absolutely loves linear thinking. Input A leads directly to output B. Simple cause and effect. It's clean, it's easy to model.
But it's not real.
But life is, as the book says, relentlessly nonlinear.
And this is where we get into feedback loops.
Feedback loops are absolutely central. In any nonlinear system, a very small change at the beginning can lead to massive, unpredictable consequences later on. This is the famous butterfly effect.
A butterfly flaps its wings in Brazil and sets off a tornado in Texas.
That's the idea. And this is where complexity theory really enters the picture. The book discusses the work of Ilya Prigogine, a Nobel laureate, on what he called dissipative structures.
Prigogine is fascinating because he totally challenged the old idea that chaos and disorder are always a bad thing.
He completely flipped it on its head. In classical physics and thermodynamics, disorder is just decay. It's entropy. The second law, things fall apart, energy dissipates, the universe cools down, the end.
A bit depressing.
Very. But Prigogine showed that in open systems, like all living systems, that instability and chaos can actually be the source of creativity. It can lead to the spontaneous emergence of new, higher forms of order.
So disorder doesn't always equal decay.
It can be the engine of creation. A crisis in a system, whether it's a cell under stress or a society in turmoil, isn't necessarily the end. It can be what they call a bifurcation point.
A fork in the road.
Fork in the road where the system has a choice. It can collapse, or it can spontaneously reorganize into something new, something more complex and coherent. It shifts to a new level of stability.
So this fundamentally changes how we view change itself. We tend to fear instability, but in living system, instability is actually the prerequisite for evolution and development.
You cannot grow, you cannot learn, you cannot evolve if you are in perfect static equilibrium. Stability is stagnation.
That's a huge insight.
Yeah.
Which brings us to the fourth one, which for me is maybe the most profound. It's the one that bridges biology and philosophy, the Santiago theory of cognition.
It is a radical departure from everything we've been taught. Remember Descartes, he said mind and matter are totally separate. Mind is some mysterious thing, a ghost in the machine.
Right.
The system's view says mind is not a thing at all. Mind is a process.
And the thesis is, the process of life is a process of cognition.
That's it. That one sentence changes everything. It means that cognition, knowing, responding, interacting, is not limited to beings with brains. It means that even a single bacterium has cognition.
Now, let's be careful with the words here. We're not saying a bacterium is conscious or that it's thinking about philosophy.
No, absolutely not. We have to be precise. But we are saying it has cognition. It interacts with its environment in a meaningful way. It senses a sugar molecule and moves toward it. It senses a toxin and moves away. That act of sensing and responding is cognition. It's a process determined by its own autopoietic structure.
So thinking, or at least knowing, isn't something that just happens inside a human skull. It's a fundamental property of all life.
It bridges the gap that Descartes created. Life and mind become two sides of the same coin. You cannot have life without this cognitive process of interacting with an environment. This completely changes our relationship to the natural world.
We aren't the only knowing beings in an otherwise dead mechanical universe.
We are part of a massive planetary cognitive web.
Okay, wow. So we have these four core insights, from parts to the whole: autopoiesis, or self-making, nonlinearity and complexity, and life as a process of cognition. Now let's do what the channel does best. Let's do some systems mapping.
Let's map it out.
Let's look at how this old machine metaphor actually plays out in our real-world institutions today. Who are the actors in this system?
Well, the book is very clear on this. The actors are the institutions built on mechanistic thinking. First and foremost, modern healthcare.
We touched on this.
We did. It treats the body explicitly as a machine. If a part is broken, you replace it or you medicate it to force it back into spec. And again, this is incredibly effective for acute trauma. If I'm in a car crash, please take me to a mechanistic surgeon.
Yes. Fix the machine, please.
But it's systemically failing for systemic issues. For chronic disease, where the problem isn't one broken part, but a whole pattern of lifestyle, environment, genetics, and stress.
And what are some other actors?
Corporate biotechnology. They treat life as a patentable commodity, like a piece of software code that can be edited and owned. Classical economics is another huge one. It views markets as efficient, predictable mechanisms that are always seeking equilibrium.
Which they never are.
They never are. They're complex adaptive systems. And then there are things like our industrial agriculture system, or even our education system, which is modeled on a factory production line.
Okay, so those are the actors. What are the incentives that keep this machine system running?
The primary incentives are control and efficiency. That's the legacy of Francis Bacon, one of the early thinkers of the scientific revolution. For him, the goal of science was to dominate nature.
To wrestle it into submission.
Exactly. We want to predict things. We want to control them. We want to optimize them for a single output, like crop yield or quarterly profits. And we treat organizations and farms like factories.
And this drive for efficiency leads directly to fragmentation, right?
Yeah.
We create specialists who know everything there is to know about one single gear in the machine.
But they know nothing about how the machine as a whole works or how it fits into the larger environment. And this fragmentation, this is the root cause of the crisis.
So we have the actors, the incentives. What are the narratives, the stories this machine system tells itself?
The big one is nature as resource. The earth is just a warehouse of dead matter for us to extract and use. It has no intrinsic value. Another one is the myth of social Darwinism, that life is fundamentally a competitive struggle.
Survival of the fittest.
Right, red in tooth and claw, which is funny because the system's view shows that life is actually much more about cooperation and symbiosis.
Evolution is largely a cooperative dance.
It is. Symbiosis, networking, communication. These are just as important, if not more so, than raw competition. But our economic and social feedback loops are stuck on the competition narrative.
Let's look at one of those feedback loops. The book uses the example of mechanistic agriculture.
It's a perfect example. So you're a farmer. You have a pest eating your monoculture crop. Your paradigm tells you this is a simple, linear problem.
Pest is bad. Kill pest.
Exactly. So you apply a pesticide, a chemical control, and for a moment, it works. The pest dies. Problem solved, right?
For a moment.
For a moment. But the ecosystem is a nonlinear web, and it reacts. The pesticide also kills the pest's natural predators, which are often more fragile. And the few pests that survive the poison are the ones with natural resistance.
And they're the only ones left to reproduce.
So now you have a new population of superpests, and you've killed off the insects that used to keep them in check. So what's the solution from within that paradigm?
You invent and apply an even stronger pesticide.
Precisely. The loop reinforces itself. You damage the ecosystem, which creates the need for more technological intervention, which causes even more damage to the soil, the water, and the biodiversity. And this loop persists because the paradigm literally cannot see the web. It only sees pest and chemical. It's blind to the systemic consequences.
Wow. Okay, this brings us squarely into the present-day implications. The book connects these abstract ideas to the very real crises we all face. Let's start with the big one, the economy, and what it calls the illusion of perpetual growth.
This is perhaps the most dangerous delusion of the entire mechanistic worldview. Our current economic models, especially neoclassical economics, view the economy as a system that is completely independent of the biosphere.
It's like it exists in a vacuum.
It does,
Yeah.
and in this vacuum, it strives for unlimited quantitative growth. GDP must go up forever and ever, amen.
But anyone who has a basic understanding of biology knows that unlimited quantitative growth within a finite system is, well, it's the definition of a catastrophe.
It's the dynamic of a cancer cell. That is the only thing in a living body that follows the logic of growing for the sake of growth until it ultimately kills its host.
Which is,
The biosphere, and by extension, us. In nature, healthy growth is qualitative, it's developmental, and it's cyclical. A child grows physically for a while, but then they stop growing larger and start growing in maturity, in wisdom, in complexity.
and ecosystems grow until they reach a stable climax state, and then they just cycle their resources.
But our economy demands to expand physically, quantitatively, forever on a planet that is very much finite. And Capra and Luisi are arguing that this isn't just a matter of greed, it's a structural flaw baked into the model itself.
The model literally doesn't account for the biosphere.
The model treats the biosphere as an externality, a cost to be ignored, which is pure insanity. The economy is a subsystem of the biosphere, not the other way around. You simply cannot run a healthy economy on a dying planet.
Let's pivot to healthcare again. We've touched on it, but the book goes much deeper into the crisis in healthcare.
It does. As we said, the mechanistic approach has given us miracles in emergency care and surgery. But at the same time, we are facing an absolute epidemic of chronic diseases.
Diabetes, heart disease, autoimmune disorders, mental health crises.
Exactly. These are not machine failures. These are systemic failures.
Yeah.
And you can't cure them by just swapping out a part or prescribing a single pill.
No, because systemic health is multidimensional.
It has to be. It involves the body, yes, but also the mind, the social community you live in, and the physical environment. If you live in a polluted neighborhood or a socially isolated community with no support or a high-stress job, your cells will know it.
Because biological structures are coupled to their environment.
They're inseparable from it. You cannot make a person healthy in a sick society or a toxic environment. The model is wrong.
And this connects to the discussion on biotechnology. The book is pretty critical of what was called the central dogma of genetics.
Yeah, the central dogma was this very linear idea that information flows in one direction. From DNA to RNA to protein, one gene makes one trait.
The ultimate reductionist dream.
It was. If we can just find the gene for obesity or the gene for intelligence, we can go in and engineer it. It treats genes like individual Lego bricks that you can just swap out.
But it turns out genes don't work like Lego bricks at all.
Not even close. The genome is part of a complex, dynamic epigenetic network. Genes are constantly being switched on and off by the environment, by your diet, by stress, by your thoughts and behaviors.
So it's a conversation, not a blueprint.
It's a conversation. And when you go in and tinker with one part of that conversation, like in the genetic engineering of crops, without understanding the whole network, you get unpredictable, nonlinear consequences. You get unintended side effects because you are disturbing a web you don't fully see or understand.
So we've looked at the economy, at health, at biotech.
Yeah.
And all these systemic failures, they trace right back to this central crisis in perception.
That is the core message of the book. Our crises are not just a string of bad luck. They're not just the result of a few bad policies. They are the inevitable, predictable result of a fundamentally bad perception.
If you perceive the world as a collection of isolated objects,
You will build isolated institutions. You will build silos. You will build fragmented solutions that create more problems.
but if you perceive the world as a network of relationships,
Then you start to build for that reality. You build sustainable communities. You design for connectivity. You design for circularity, where one system's waste becomes another system's food. You realize that waste is a concept that doesn't even exist in nature.
and this is the deep continuity with our channel's theme. Structural change cannot happen without a shift in human consciousness and perception. If we just change the politicians, but we keep the old mechanistic map,
We're just rearranging deck chairs on the Titanic. The underlying structure of the problem remains.
awareness without structural change is useless. But structural change without a shift in awareness just reproduces the crisis in a new form.
You have to see the system to change the system.
As we start to wrap this up, let's just reflect on the major shifts this book is calling for. It's a move from seeing parts to seeing the whole.
From seeing objects to seeing relationships. This is a big one for our culture. We love things. We love nouns. But systems thinking is about verbs. It's about processes. A mountain isn't just a rock. It's a process of slow geological uplift and erosion.
From just measuring things to mapping their patterns.
Right. We are obsessed with quantity, but we need to get much better at understanding quality and pattern. You can't measure the health of a family just by counting the calories they eat. You have to map the quality of their relationships.
And from seeing static structure to understanding dynamic process.
Everything that looks like a solid structure, your body, a corporation, a tree, is actually a slow-moving process, constantly exchanging energy and matter with its environment.
The book aligns all of this with a philosophy called deep ecology. What's the distinction there between, say, shallow ecology and deep ecology?
It's a crucial distinction. Shallow ecology is about tinkering with the machine. It creates regulations to protect nature so that we can keep exploiting it a little bit longer. It's still fundamentally anthropocentric. It's human-centered. We protect the environment for our use.
Okay. And deep ecology?
Deep ecology shifts to an ecocentric participation role. It recognizes, based on the science we've been discussing, that we are not separate from the web of life. We are a strand in it.
So doing harm to the web is literally doing harm to ourselves.
It's not just a nice moral stance, it's a statement of biological reality.
And that, I think, is the final thought I want to leave with you, our listeners. The solution isn't better control of the machine. It's a fundamental change in the metaphor we live by. We are not operators of a device. We are participants in a living network.
Well said.
So what does this all mean for you personally? It might mean looking at your own life, your health, your work, your community, not as a checklist of separate parts to be managed, but as a garden to be tended. Where are the connections? Where are the feedback loops?
And just remember, in a nonlinear system, small, well-placed actions can have vast consequences. You are a part of the web. Your perception and the actions that flow from it really do matter.
We have to give huge credit to the authors Fritjof Capra and Pier Luigi for their incredible synthesis in the system's view of life. If you want the deep mathematical and biological proofs behind everything we just discussed, and believe me, it is all in there, you really should pick up the text.
It's a dense read, but it is incredibly rewarding.
This project is free and publicly accessible. If you'd like to support the time, tools, and research behind crisis and perception, you can become a supporter on Patreon.
For a shorter visual overview of this topic, see the mini explainer linked in the description.
If you enjoy this kind of systems-level analysis, please like, subscribe, and comment with books or topics you'd like us to explore next. Thanks for listening.